So integration by parts sometimes works super nicely, but integration by parts could be tricky sometimes, and it can seem like it's not working or not getting anywhere when it really is. And so I'll show a couple examples of where you have to use integration by parts more than once to get to the answer. So you could have a situation like this, where maybe you have x cubed times sine of x dx, and you're like, okay, I know that if I take the derivative of x cubed, it'll get better. And if I take the antiderivative of sine, it doesn't get better or worse. It stays basically the same. So du would be 3x squared dx, and v would be negative cosine x. So we're making a little bit of progress. Here's our u v minus the integral of v du. Didn't get too much better. It got a little bit better. Now we're down to an x squared problem. Okay, well, you just do it again. Let's have u equal 3x squared and dv equals cosine x dx. So then du is 6x dx and v is sine of x. So now we're down to this. We still have got negative x cubed cosine x. We've got another uv minus the integral of v du. Hope you can see how we're going here. We got one more integration by parts to do, where u equals 6x and dv equals sine of x dx. So du is 6 dx, and v is negative cosine x. And so I'm going to move my face out of the way, and this is going to be the full antiderivative. Just be careful with your positives and negatives. So I'm subtracting because my integral was being subtracted. So I'm subtracting this. uv is going to be negative 6x cosine x minus the integral of v du. And I'm going to try to follow through this. So that makes that positive. And I'm going to distribute that negative and do one more integral. So we have negative x cubed cosine x plus 3x squared sine of x plus 6x cosine x, and that's going to be 6 sine x, and looks like it's going to be minus sine x plus c. And somewhat amazingly, if you take the derivative of all of that, you should end back up with this piece right here. And you can kind of see how that would work by thinking of it like a telescoping sum. If you take the derivative of each of those pieces, you're going to use the product rule on this, product rule on this, product rule on this, and each of those product rules gets canceled out by the next term's product rule. This one right here eats up the last piece of this one right here. And I hope you can see how taking the derivative of this first piece will lead you back to the beginning. So sometimes you just need to put your head down and do integration by parts over and over again. This usually happens when you have a polynomial piece times an exponential piece, or a polynomial piece times a trig piece. Because the trig and the exponential just kind of stays the same, and the polynomial goes 1 degree less every time you do integration by parts until you get down to your final antiderivative. So that's an example of doing integration by parts more than once. In the next video, I'll show a slightly fancier example of repeated integration by parts where it cycles back on itself. So please ask questions. Let me know how I can help.